Everybody, Jason here. Hope you're all doing really good. Today I'm working on a Galaxy S20 FE that was sent here for an FPC connector replacement. So of all of the connectors that could be broken on this phone, they decided to break the absolute largest connector on here. Now, whenever I first witnessed this damage, what I observed was only on this side. And looking at this end of the connector, this was originally broken, and this connector was just kind of like smudged out right here, and the pins were just sort of out of shape. So I figured I would go ahead and just bend this thing right back into place. And then I added a little bit of solder here because it was physically broken right here at this point right here. And I was just, so proud of myself. And then I decided to go ahead and, inspect the rest of the connector last. And zooming over to the other side of the connector here, everything just looked great, except it was missing a pin. Like, seriously? It's so hard to see this, even with a microscope. Like, let's just get real close here. And looky here. Part of this pin is freaking missing. Wait, is it just pushed back in there? Is that just pushed back in there? Oh, wait a minute. I might still be able to cheat after all, right? Okay, fresh X-Acto blade time. Yeah, I mean, just look at the size of this connector. It's just like the connector that never ends. It just goes on and on, my friend. Some people started soldering it, and they'll keep soldering it forever just because it's the, however that song goes. In other words, what I'm trying to say here is that if I can get away with fixing this connector and not actually putting a whole new connector on it, that's what I'm going to do, because that is actually less stressful on the board. I'm not going to sit here and bake this whole area to replace this connector. Plus, I mean, this connector really don't look that bad. And like I said, when it first came in, it looked like it was just this side that was messed up, and I soldered that back together and soldered it all together, and everything looks great. But this pin over here, this is most likely what caused the problem that caused it to get sent in here, but it looks like it's just recessed. I wonder if I can fix it. By God, I'm sure going to try. I sure am going to try. So, what if I just give it the old-fashioned battery data line adjustment? You push on one side of it and see if you can draw it out of there. Oh, here it comes. Ooh, and a new pin was born. Sort of. You know what this means? It's like a perfect connector again, and you know what this means? This means, since I'm leaving the genuine Apple component on here, I can charge like $500 more. Boy, am I glad I didn't just dig in and start soldering here. Now let's give this connector a benefit of the doubt, though. I mean, now I do wonder what the little cracked up places here on the bottom of this connector is. Like, do these connectors fall apart? It looks like it's just falling apart into bits. I'm sure that's not really good. Oh yeah, look at it. Oh yeah, this connector is falling apart. This is snapped inside. That's why it looks like that. See it moving? This black piece? It's completely snapped off and broken away from the main part of the connector. And this is like not just one of them. It's snapped like that all the way down through here. Every single one of these is broken. Huh. I'll be danged. Well, I guess I'm not going to be able to charge that extra $500 because I'm going to have to replace this connector anyways. Alright, so we've got the top part of this board. Should be ready to pull it out of the housing. Let's see what happens here. Oop, you know what I'm forgetting? SIM tray. I do that every time. Every stinking time. Alright, let's see if it'll give. Sometimes Samsung will use more than one screw. Looks like this camera's probably holding it, right? Oh yeah, baby, there we are. A nice non-sandwich logic board. I'm pretty well sure I could get away with not replacing that connector. I'm just going to be extremely careful not to melt anything under here. And what do we have here? Is this a rubbery pad thing? Because, let's see. These things like to melt. Pretend like that didn't rip. Let's give it the old hot air test. Nah, that's not a sticker that's going to melt. We're just going to leave it. All right, I've got this board sort of put down into a holder, like sort of. I need to make sure I do, in fact, have the proper connector before I remove this, because I've got a promise to have this phone done today. And actually, 2 days ago. I ordered these connectors from Mobile Centrics, and by the way, I'm thrilled to say that these guys have lots of this stuff in stock. Let's see if these are the proper connectors. One per package. It's kind of a waste of packaging, but that's okay. I'm probably, most likely, only going to use one. Honestly, I could most likely get away with not replacing this connector, but this is a really new phone. I mean, this is a Galaxy S20. The chances that it's going to go through another repair and have this connector disconnected and stuff in its lifetime is actually significantly high. If I don't replace the connector, the next person or the second person or maybe even the third person to disconnect that connector, they're going to pop it off there, and then they're going to get a huge chunk of plastic stuck inside the cable that was plugged into it, because it is literally broken. That's a 78 pin connector. It's broken in like 79 different places. Yeah, it would work. But I have a conscience. I like to be able to sleep at night. So, much like you see me doing on iPhones, the first thing I do on this sort of thing is try to get rid of the lead-free solder. And to do that, I'll just flood the existing connector there with flux. Now I'm going to begin taking 6337 leaded solder and just kind of start flooding all these joints with it. Yeah, this connector really is easy to get to, so there's not, I mean, other than being like big and intimidating, there's not really any good reason for me to just not replace it. You know, other than if it was fine. You know, if it wasn't like all busted up and cracked up, then I may not have replaced this connector, but this thing, it's in bad shape. Okay, that's got all those inside pins flooded. Let's go ahead and flood the outside pins. Now I am using the hot air here to sort of preheat the board. It really helps a lot to raise the temperature of the board, especially when it comes to these ground joints. Dang it, I just soldered both of those test points. When you're doing one of these, try not to put solder on the test points. It doesn't hurt anything, it's just frowned upon. So, shame on me. And here I think you'll probably see that connector come apart in two different pieces. Yeah, there's one piece. It was broken into two pieces there, and I microscopically soldered it back together, and man, I was proud. And it probably would have worked now that I see that other pin was just recessed, but we don't want to do that. Not today. Not for these guys. This is for a repair shop customer, and they've been really good. All right, almost. Let's see if I can go ahead and snag this end cap off of here. There we go. Now I think I have got this, enough of this switched over to leaded, so I can just start kind of taking it off the board. All right, so I'm just going to start warming up this whole area. I'm going to set my hot air to 340 degrees C with an airflow of 40. This is too hot. This really should be more like 300-ish, but we're going to do this at 340. I'm just going to be really careful. See it just start to melt, and as that starts to melt, I'm backing away because I don't want to melt the lead-free stuff on the other side of the board. So as this starts to melt, back away, pick up, back away. And I'm just going to probably take it off the board in pieces. Let's see. There we go. Yeah, this connector is broken all the way, the full length. It's snapped. Almost. Come on, baby. Alright, I think I am going to just go take the whole thing off. There we go. No! It went everywhere. Now I get to fish pins off from all over the board, right? That connector is broken into bits. And I could have sent that out the door. Be like, oh yeah, you're good to go. Just like brand new. Perfect. So here's our connector. That's what's left of it anyways. Now at this point I could go ahead and wick these pads off clean because it's all really easy to get to. But ultimately my goal here is to have nice big old fluffy leaded pads. So I'm just going to go ahead and just use my iron to do that and not bother with wicking it. That's a step that I can just eliminate on this one. So we just want these pads to be just about as fluffy as we can get them. I will still wind up going through and hand soldering some pins, but for the initial placement of the connector, I like to have the pads tinned. Now, this flux is all starting to look pretty stinking burnt, so I'm going to clean that off, and I'm going to go with some fresh flux for the fresh connector. There we go. It's not a perfect amount of solder, but it's going to work out pretty good. Okay, let's get the new connector out of the package. You know the components are small whenever you are compelled to unpackage them using a microscope. Brand spanking new connector. And I'm not kidding, it is actually a brand spanking new connector. All right, so I'll just sit that connector right on out of the way. And we need some flux on here. I know I just cleaned it off, but we need more on here. So we'll just get some right along here. Some nice, fresh new flux. Oh yeah, it's pretty. And we're just going to sit this big old honking connector down on here. And I'm going to start warming the board up. But I'm actually going to go ahead and reduce airflow. Oh, I don't know, maybe 20. We want the board to warm up under this connector. And we basically want the board to raise the temperature of the connector instead of trying to use the connector to raise the temperature of the board. And as this reaches the magical temperature, it should sort of kind of start settling into place. But before it does, we will see flux bubbling. I'm going to be leaving this part of the video in real time so that everybody can see exactly what I'm going through to get this connector to just sort of line up with all those pads. I mean, it is a really, really big old long connector, isn't it? Come on. We got this teeter-totter thing going on that's actually caused by my humpy pads. Come on, baby. I really should have just went ahead and wicked this off completely clean. That way the connector would sit flat on the clean pads and then soldered each pin by pin with an iron. I think that's actually the acceptable, proper way to do it, but I usually wind up fluffing the pads up and then just floating it right into place. Except this connector here, it's just a little bit long. All right, we're coming up to temp here. This thing is just about to start floating down onto the board. Starting to look pretty good. Come on, baby. All right, that's starting to melt as it should, and it's really something to see the solder melt before the plastic. Now, I imagine this is a pretty high temp plastic, but before I started soldering, you know, I guess I had a misconception about the melting point of things, because this solder will melt way before the plastic. The connector's so big, I'm having trouble floating the whole area. I'm really wishing I would have just went ahead and soldered this all with an iron. That's what I should have did. Okay, I'm almost there. All right, I'm an entire pin off. Isn't that lovely? Okay, so now I'm actually going to try to heat this whole thing up and then just kind of shimmy that connector to the right one pin, because we're hanging off on the left-hand side here and not all the pins are lining up. Okay, we're going to need some flux in there. There we go. So 340 is actually a pretty good temperature right here. If I was to lower my air any at all, I would not be having any luck whatsoever, because I'm really just right on the edge here of what's hot enough. This is not quite hot enough. Okay, here we go. Just about up to temp. Come on, baby, let go. All right, there we go. Now, one more pin over. Just about right there is where it needs to be. I'm just going to nudge around on it a little bit here and see if I can't finagle this thing into being lined up the way that it's supposed to be. Would have been so much easier just to solder it with an iron. But, you know, here I am. Almost there, baby. Yeah, there we go. Yeah, if I could choose to do this one over again, I would have wicked the pads off clean and did this first soldering with an iron. That would have been so much easier. Okay, looking good. Let's not bend the connector up. Come on, come back a little bit. There. All right, we're going to leave it just like that. I'm going to flux it, float it, and then I'm going to hand solder it. Because this is actually looking pretty decent. Okay, there we go. Now one float here without touching it. And honestly, could probably just leave it like that. This would be a happy phone. But I am going to go ahead and solder this properly. This is the Hakko FM2032 micro pencil with the 0.1 millimeter conical tip. Links are in the description, although mine is just a little bit smashed up. Time for a new tip. I'm getting it, but just barely. There is that side, completely done with the iron. Now I'm going to flick it around here and do the outer side. The bottom row of pins there. And these will be quite a bit easier to get to because I can like lay my iron down flat. All right, now that I've got a pretty equal amount of solder all the way across the entirety of that connector, I'm going to give it one last float. And this is going to make everything look nice and uniform. Now I'm going to start warming it up primarily here on the left-hand side, and I'm just going to try to, I'm going to try to get the heat to flow from the left to the right. Almost there. There it goes. There we go. That's pretty well melted all the way across. Now I'm just going to go ahead and clean this off with some isopropyl alcohol. Otherwise, you really can't plug anything into this tacky flux. It sets up sort of like concrete. Alrighty then, that has our connector repaired and actually replaced, and it looks marvelous. Under the microscope, everything actually turned out looking a-okay, and we do not have any solder bridges. And on the inside, we have the same sort of okayness. Now, just to give everybody a really good perspective as to how small this connector is, this is your standard dinner issue toothpick. And if I take the connector that I just installed here and I lay that toothpick right on top of it, the toothpick will actually cover almost the entirety of the connector. That connector is only as wide as a toothpick. All right, but does it work? I think it's going to work. I hope it works. So the FPC side of this actually looks moderately okay. Will it give us a nice little click? Huh? Huh? Oh yeah, baby. That actually feels really good. Let's see if it'll charge a battery, shall we? Woohoo, we have battery chargeage. Looking good so far. Welcome. Hey, this is actually a fresh restore. How about that? Let's see. An unauthorized attempt has been made to reset your device. Yeah. Okay. Well, we'll deal with that a little bit later. It sure seems like this customer was wanting the data that was on this phone, but there's not going to be any data on that phone. So anyways, guys, that is a successful connector replacement on a Samsung Galaxy S20 FE. And aside from that being blank, I suspect that this customer is going to be completely happy. So that's going to be the end of this video. I will see you in the next one. Have a good day, everybody. Thanks for watching. Your phone was factory reset. Enter your passcode to unlock it. So to the customer that sent this here, job ID 7482, if your customer was really wanting their data,